the second part is, how do we relate the signals to the actual prices? Okay. And we've already done this before. So if you look into our backtest, you can see here, when we calculate our unrealized P&L, yeah, we've got this times in pos. And effectively, what we created on below is like the time-wise representation of in pos, right? In pos +1, -1, +1, and so on. So all we need to do now is, you see, these are our returns here, percentage returns. And all we do is we multiply them with in pos. And that's it. Interesting, huh? So how do we do this? and we do this effectively in bulk. So we've got this signal thing here, yeah? And all we do is basically do SPY dot close dot, and you remember percentage returns, yeah, is a dot PCT change. Yeah, it's the percentage. So in pandas, instead of having to write out today's price minus yesterday's price divided by yesterday's price, all you do is you just go spy.close.pct change, and you get a percentage change. Now, if we do this, there's one big gotcha. There's one big problem. Now, actually, so what we can do is we can wrap this into brackets, and we just go say dot, and then we just calculate the cumulative sum of this and plot it. And that's our whole backtest. And look at this. This is like, wow, this is amazing. Why is it so amazing? What's the problem here? It's obviously far too good. But what's the problem? It's an interesting question, and I'm asking you this specifically, and I don't expect you to give me a great answer. But the answer to that is really, really interesting.
I think, like, now I'm not sure, but like, I think we've overfitted it, so to say, because we now know backwards, like, when it is short and when it is long. So yeah, we just made it perfect, kind of.
Actually, that's right. It's what's called data snooping. Because think about this. We align the dates of these things, right? And so when we look at the PCT change, the percentage change here, we actually have the trading signal from today and the percentage change from yesterday to today, right? But what we actually want is the percentage change, because we get the signal, and the signal applies to the percentage change from today till tomorrow. But what we do is we're looking back. So we're actually predicting the past rather than the future. And because we already know the past, boom, we get this amazing performance, which is obviously really unrealistic. And what that shows us is if you make tiny little mistakes, it can go really bad. Like you get these inflated, like you go, oh my God, I have this amazing strategy. But it's actually, all you have done is you've fallen prey to what's called data snooping bias. Okay. So this is really terrible. And what do we have to do? We have to shift our time series, our returns, So we've got the signals, right? But what we need to do is we need to basically take the returns and we need to shift them by 1. Yeah. Now the question is, so there is actually a very convenient shift function in pandas. It's just called .shift. Yeah. And it effectively shifts our series. Now, my question to you is that this is a really difficult one. and you've got a 50-50% chance of getting it right. Do you shift it by 1 or by -1?
Yeah, I would say by -1.
Okay, why?
Because, like, with the iLog, I think, if I remember it right, like, we're either going like minus days, so into the past, kind of, or plus into the
Mhm.
future. And I think we cannot go really into the future. I mean, we can now that we know like the past, but we cannot in practice, so to say, in reality. So we need to go back.
Correct. When you think about it, right, we've got two time series, right? And the top one is effectively our returns, and the bottom one is our signal. Now I'm doing this on my screen, so I'm not really sure. But in order to get the next day, we have to actually shift the returns back. So then today's signal is aligned with tomorrow's returns. So -1 was the right answer. Okay. So let's just do this. And boom, here is the result of 200. So it's not a particularly glorious performance. Now it's a little bit worse than I would have expected it
But
to
isn't it
be.
because we took like a different number? Ah, no, yeah.
Yes. But let's just do 250. Yeah, so it's not as good as I thought it would be, because it doesn't actually align very well with what we have done here. We went to 195. So you would have expected that to be a little bit better. So we've got the percentage change and the cumulative sum and the moving average. So that should all be good. So let's just let's just look at this. Now, another way to do this is we actually instead of shifting our returns one way, what we could also do, of course, is we could shift our signal the other way, right? And that should give us the same performance, which it does, right? So the important thing here is to really, be aware of okay, how do I shift my signals back and forth? And let me just quickly check what we've done up here, because I see. Okay. So look at this. We've actually added something else here. We said we actually added a stop loss to this. If we see if the return is there, that's why it performs much better. Now, this is a good idea, but actually, when you do vectorize, this is actually a lot more difficult to implement, and we come to this later. So what we should do maybe is, for now at least, what we can do is we can actually copy this line, and then comment that out. Oops. And then get rid of this thing here, yeah, and rerun it again. And so if we rerun that, hopefully we should see a much more, see, now we got the similar result here, yeah. So this is just a not so great strategy, but it actually doesn't really matter for our current investigation. But what's really interesting now is the question, okay, we built the same strategy as this one above. How long does it run?